presentation on Spring dependency injection styles. My name is Chris Beams. I'm a committer for the core Spring framework, and I've been doing that for some years now. Before that, I was a longtime user of Spring since the early days. And in my time with VMware, I've been a consultant around Spring technologies, done lots of training, and it's really been my pleasure to be a committer for the last number of years. So, welcome. A quick agenda is we'll take a very quick review of dependency injection itself, independent of Spring. Many people on the call may be quite familiar, some may not, right? So we'll take a quick tour of that. Then we'll look at how Spring addresses this idea of dependency injection. And there are a number of different approaches today, XML-based, annotation-based, even pure Java-based dependency injection styles in recent versions of Spring. And we'll explore all of those live in code, in Eclipse. And along the way, we'll talk about some of the pros and cons of each style, and ultimately, we'll talk about how really it's about mixing these styles, talking about independent different styles in Spring is a bit of a historical exercise, talking about the evolution of Spring over time. Today, both XML, annotation-based, Java-based, they really work together. They're really designed to work together. And that's where we'll arrive, but we'll get there in steps. And I'd really like to make a point about this. I'll leave this slide up for a few seconds here with these URLs. The first one is the URL of the presentation you're watching right now. So it's live online, and it'll stay that way. You can follow along now, or of course after the presentation at your own pace. Also, all of the projects that we go through today are available basically in that same project at GitHub. And I'd really encourage everyone to take a look at those, to check them out. There's a simple README file that you'll see at that link that explains how to do it. And particularly after the webinar, you can go through those again at your own pace with your coworkers, with your team, et cetera, and explore. It's really designed for you to do that. It's not just for the webinar here today, but it's for going forward as well. Also, just a kind of housekeeping note, we know from the previous webinar that we gave today that there may be some latency for certain listeners, even up to 2 or 3 seconds. So you may hear me pause just briefly when I'm moving around code or moving around slides. It's just to make sure, or to give the best shot at anyway, making sure that everybody's seeing what I'm talking about when I'm talking about it. So let's talk about dependency injection as a concept, as a topic. And to focus on that, we'll just look at a very typical kind of component. Let's call it transfer service. And you'll see that the projects that we'll be looking at in the IDE are all based around a financial domain, a banking domain. I wouldn't be surprised if more than a few callers on this webinar work for banks, so it's even a likely domain. Let's just start with some simple code. If this is our transfer service, so an application component, a business component, this is where the logic happens, right, of transferring some amount of money between 2 accounts. This transfer method might be being invoked by a web component like a controller or a servlet. It could be being invoked by a nightly batch process. In any case, the idea is that we have a simple, plain old Java object transfer service that represents our business logic. And you can see what it needs to do. It needs to look up by ID these 2 accounts, the from and to accounts, debit from one, credit to another, the work of performing a transfer. It might be an ATM that's ultimately invoking this. At any rate, the question is, we have a dependency, transfer service has a dependency on accounts. It literally needs to call methods on that object. Where does accounts come from? How do we get hold of that accounts object? There are certainly multiple options, multiple approaches that could be taken. One would be simply instantiating the object right in line in the transfer method. You might call this a direct instantiation, and it's really not a great option because while transfer service has a dependency on this account repository, the account repository probably also has dependencies. In this case, it's a JDBC-based account repository. It probably needs a JDBC data source, which will be many more lines of code to create. It'll get pretty ugly pretty quickly if we take this approach. A second option would be maybe you have somewhere in your system a singleton-style object, a singleton factory that encapsulates the logic for creating a data source. And okay, maybe we make a static method call into that singleton to get hold of the account repository. It's a bit cleaner, but it's still not a great option because at this moment, the transfer service is really statically tied to the particular logic in that factory, to the particular data source that it creates, to the particular properties that it looks up, etc. And most of all, it's tied to actual underlying infrastructure, the production infrastructure, probably, at this point, which means that it's going to be quite difficult to unit test this class. A third option, a common one, would be doing a JNDI lookup. It's not a great option for similar reasons. The most important one is that, of course, for a JNDI lookup to succeed, we have to be inside of an environment that has JNDI available, i.e. An application server, which means for sure we're going to have a hard time unit testing this class. So, and we could go on. There are other possibilities, but these three represent a category, a style, maybe an anti-pattern that you could call dependency lookup, where the component in question, transfer service, needs to bother itself with the work of finding its dependencies, looking up its dependencies. And this always makes the component inflexible and very importantly, difficult or even impossible to properly unit test. And by unit test, I mean like JUnit test, where you're running outside of the container in an automated fashion from continuous integration, for example, or just from within your IDE. So what's the alternative? Obviously, dependency injection would be the opposite of dependency lookup. And that's really as simple as, in this case, introducing a constructor. So transfer service now has a constructor that accepts the account repository object that it depends on. We get many benefits from this. First of all, the transfer service is once again a very simple object. It really is a plain old Java object, this idea of a POJO, right? It means that unit testing is going to be quite simple. We could pass in a fake, dummy, mock account repository, for example, that doesn't need to be tied to underlying, real live production infrastructure. And it also means that the transfer service just does one thing and does it well. It knows how to transfer money. It knows how to look up accounts from an account repository and how to transfer money between them. That's this idea of the single responsibility principle. And we've now achieved it with this design. So you might look at this and think, there's really nothing special here. And that's correct, that's accurate. This is really just plain old Java as it ought to be. Dependency injection really is that simple. Whether you're using a constructor and or setters, Java Bean style set methods, what matters is that you're not doing dependency lookup. You're not creating these fragile, statically coupled architectures. You're keeping things loosely coupled, a supple architecture that's quite flexible and reusable over time. You might just say that dependency injection is object orientation done right or done correctly. With that said, it's not necessary to have Spring to do dependency injection. Sometimes these two words kind of go hand in hand because Spring helped popularize the idea of dependency injection in the Java world. But dependency injection is a concept all to itself. Spring just helps with it. So you don't need Spring or any framework necessarily to do DI. And to demonstrate that, let me walk you through, let me first introduce you to these projects, and then we'll look at a project that indeed does create this kind of system without any Spring involved at all. But first, just generally, each of these projects contain the same code. It's all this style application. It's very, very, very simple, just for the purposes of an hour like this so that we can look at the different styles and so on. So you won't see any rocket science in here. But it is just complex enough to represent maybe what would become a real-world application. And in the app package, ComBank, this transfer script, look at individual lines in this in a moment. But if you just focus on these last couple of lines, we've got hold of this transfer service object, and we're going to call transfer some amount of money. In this case, we're generating a random amount between $10 and $90, and then transferring between these two accounts. If we run this, just running a main method, you can see what the application is designed to do. Right? Transferred, in this case, $60 between these two accounts. Here's the remaining balances. Very, very, very simple. Okay, let's look a little bit at the individual components then to get a bit better sense of how the application works. We have interfaces involved. There's the default transfer service, which we're looking at here. You can see default transfer service implements transfer service. It has, of course, this transfer method. And that's where you can see the real work of the application is getting done. This is where the business logic lives. Right? And you can see it's pretty clean. Like, you know, if you took just a minute to read this, you'd have a great sense of how this part of the application works. Getting a couple of these, looking them up, checking, error checking, right? Calculating a fee for the transfer, debiting one account, crediting another, updating the balances against this account repository object, right? So you can imagine, you know, maybe you call this a data access object or DAO, repository, all the same thing, an abstract for data access. We've debited one, credited the other, so we're going to update the balances. And finally, just return a receipt that indicates what's happened. So that's the meat of our application. It's pretty simple. Okay, the repository then, JDBC version of it, is accepting a data source, a java.sql.data source, right? And here, we're using a bit of Spring. If you notice, the name of this project is style 0 no Spring. What I actually mean there is no Spring involved with dependency injection. We are actually a little bit of Spring for data access, which is actually a different concern. So when you see this JDBC template, yeah, that's a bit of Spring in here, but it's not dependency injection. We might talk more about JDBC template later. But again, you can see that this is a really simple component. The repository needs a data source, and it gets its job done talking to the database. Okay, let's look again at the transfer script. Same method. This application, as you can see, is actually pretty well designed, or it's at least designed with dependency injection in mind. So, and like I said, we don't have to have Spring to do dependency injection. We can just do it on our own, right? We're creating a data source here. In this case, since it's a simple test application, it's in database. We're giving it its schema to create some seed data so that we have a couple of accounts. And then, like most applications, we have some properties to deal with. And you can see that file over here, app.properties under ComBank config. That's where we're going to get these values like flat fee.amounts, minimum transfer amounts, etc. And those properties, just like any application, just being used, it's better to have them flexible in a properties file than hard-coded in code. But you can see they're being used to configure just what is the amount that we charge someone when we do a transfer. What's the flat fee policy? What's the minimum transfer allowed against this transfer service, etc. And you can see along the way, we're just calling into normal Java constructors, calling into a normal Java Bean setter. So this is dependency injection at work. And I wanted to demonstrate that before we get into anything with Spring, so that there's no magic. What Spring will be doing for us is helping with this process, making it less verbose, et cetera, et cetera. One thing noting here before we move on is that we have a main method do all this work. That's the actual application. But we should probably also have some tests. And in transfer service tests, which I'm bringing up right now, you can actually see in the setup method of this JUnit test, the same work needs to be done because we need to recreate that application just like it's going to be in production. This is an integration test. Recreate that environment so that we can then call some test methods, like test transferring $10 between one account or another. And just to run it for good measure, now we can see the green. We've transferred $10, right, and proven that. But along the way, we had to repeat ourselves with this dependency injection logic. And that's not really ideal, especially if you're writing lots and lots of tests or you have different parts of the system that need a transfer service. You're repeating this code. And that might lead to, well, creating a factory, creating a transfer service factory object that encapsulates this logic. And you'll tuck that away somewhere in the application, maybe underneath the config package, and now you have a factory, right? And that process might repeat itself for all of your various components. And as the system gets larger, you have more and more of these factory objects that do dependency injection for you. So with that, let's go back to the presentation, see what we've learned. So we just saw dependency injection in action with no Spring involved. So you might say this is like rolling your own dependency injection. Nothing fundamentally wrong with this. There are some benefits. You didn't have to think about a third-party framework. You didn't have to learn Spring or any other framework. But like I was pointing out, you'll probably end up duplicating code in anything but the most trivial system. And like I was saying, this probably results in the creation of these kind of factory objects, like the factory design pattern. It's a natural evolution. And if you do this long enough, you'll end up creating your own framework. If you do it for a really long time, you'll maybe end up reinventing Spring or something like it. And generally, this is probably a waste of time. Unless your business is creating frameworks, and it's probably not. Your business is probably, if it's a bank, it's dealing with money, right? It's a waste of time with regard to the application at hand or to the domain problem. Okay. In comes Spring and the Spring container. And you could say that the Spring container, one of the goals of Spring is to be the only factory you'll ever need. So allowing you a generic mechanism for configuring this dependency injection logic in whichever fashion you care to, whether it's XML or plain Java or annotations, so that you don't have to do it by hand, so you don't have to create these factories, et cetera. And it's really important to note that Spring is about much, much more than dependency injection. But dependency injection is the foundation that makes so many other things possible in Spring, like declarative transaction management, which I'm sure many of you, use every day, the @transactional annotation and so on. All of those really powerful features are based on the foundation of dependency injection that Spring provides. With Spring in the mix, it means that we can go from code that looks like this, which is the code that we just saw in the first example in that main method. It goes from looking something like this, pretty verbose, pretty manual, maybe error-prone, etc., to code that looks like this. Same main method, ultimately the same transfer method getting called at the end, but the code that you're writing is greatly simplified. And it's not such a problem to duplicate this. If you had to create an application context in the main method and create one in a test, it's not too much of a burden, right? So let's look at the first style of Spring dependency injection, which is just plain old Spring Beans XML. Many people on the call would probably deal with this every day. It's been around since the beginning, right? This is the first dependency injection mechanism for Spring since 1.0. It's simple to understand. There's not much to it in terms of what's possible in the Beans XML schema. It's totally general purpose. You can configure just about anything in a Spring Beans XML file, and therefore it's very flexible. And again, it gives you access. It acts like the foundation to these higher level features like transaction management or declarative caching or many of the other features of Spring. So let's look at the next project then, style 1 XML, and see how it differs in comparison. This is again what the main method looks like in transfer script class, same main method, but all of that kind of dependency injection boilerplate is gone now. Of course, it had to go somewhere. We see that the Spring application context is being created with this app config XML parameter, so no surprise, that's where the dependency injection logic now lives. But after that, it's the same business, right? Getting hold of the transfer service, grab the container, and then calling the transfer method. You can also see in the test, that same unit test or integration test that we were just dealing with, the setup now a lot cleaner too. Creating the context, grabbing the objects necessary, and then running them through the test methods. So of course the question is, what does that XML file look like? And here it is, app-config.com. This is probably familiar to many of you. And we won't go through every single bean in here, but just to get a sense of the style. Just like we had in code, we had to deal with looking at properties, creating a data source, instantiating each of our transfer service and account repository components. Of course, we need to do those things here as well, but it's being expressed through XML, right? Our data source being created, and so on down the line. There are also some other things in here, like transaction management, like I was mentioning. And if we have some time at the end, I'll come back to that and show you how it is that Spring's dependency injection acts as this foundation. But for now, you can see that it's kind of like we've translated this configuration over to XML. And that ends up being pretty nice, actually. It's flexible, right? It can be edited without recompiling, and so on and so forth. There are a number of benefits. One of the things that's not so nice is it's a bit verbose, at least as we're looking at it right now. This could quickly grow to be many, many lines of XML. Curve that as we go forward. One of the biggest benefits to Spring's XML-based approach is that it's centralized. It acts as a kind of blueprint for your application. There's one place in the system that you can look to and say, how is this whole thing wired up and built? Even if you break your XML up into a few different XML files, the answer to the question is it's in the Spring XML, how this application wires together at runtime. That's a nice feature. Another nice feature at this point, years later, Spring's been around for a while now, is that Spring XML is very well understood in the industry. Most enterprise Java development shops have or are dealing with Spring. So if you know this, you can easily move in and out of those projects. That's a nice feature. But like I said, if you're not careful, Spring XML can kind of grow out of control. It can be very verbose. And yeah, it's not type safe, right? It's XML. You're putting a stringified class name in an XML file. So you're not going to, by default, have all the features of your IDE. Again, at this point, years later, all of the IDEs out there, Eclipse and STS, IntelliJ, NetBeans, they all have generally fantastic Spring support. So that's less of a problem, but yeah, that could be a complaint as well. So let's take the next step, right? The next step in this, again, kind of historical look at Spring. The next major evolution that came along was this idea of additional namespaces, not just one Spring Beans XML namespace, but a number of other namespaces as well. And these may look familiar to you. Context, property, placeholder, etc. We'll see some of these in action in a moment. This idea of additional namespaces for Spring came along in 2.0, and we've been adding to them ever since in 2.5 and 3. The nice thing is that they have a lot of power, but they're also really concise. So you don't see this kind of sprawling XML problem happen when you put these to use. And with many of these namespace elements, many of them are not about dependency injection, but rather they're about switching on or configuring higher level features of the Spring container, again, like transaction management. And we'll see some of those as we go forward. Take a look at what happens when we bring namespaces into the mix. Same application, same main method. Indeed, the main method in TransferScript doesn't change, right? It's exactly as we had it before, because it's still fundamentally being bootstrapped by XML. It's still an XML-centric configuration style. So nothing new here. If we look at app config, some things happen. Before we had fully qualified class names, fully qualified Spring class names for components like property placeholder configure. And now on that first line, you can see context property placeholder, dealing with getting hold of our properties for us so that we can inject them or so that we can replace values like you see here with the braces. That's a very, very common convention in Spring applications. If you have a Spring app, you probably do this right now. But nicer to have a one-liner, context property placeholder with nice documentation available in the IDE, etc. We're using the JDBC namespace to really conveniently create and populate an embedded database. That's nice when you're just getting started with an application, especially, or in the dev version of an application where you might be using an embedded database. Same thing with transaction management. It's gotten a lot simpler, actually. If you compare this to the previous version, much of the XML that was there was about configuring transaction management. And now it's gotten quite concise. And you can even see these icons showing up in the gutter of the editor. This is indicating that this TX annotation driven element is working. It's applying transactional advice to our transfer service. And again, maybe we'll take a look at how that works if we have time at the end. But the point is that it's getting pretty, and the XML that you see here now, in terms of the the overhead of writing it compared to the value that it provides as a blueprint, the ratio is starting to look pretty good. And there's not really any line in there that's not expressive, that's not providing some value. It's all pretty informative, and there's not too much noise. Okay, so not bad. We'll see if we can make it even better as we go forward. So with namespaces in the mix, we get rid of potentially a lot of XML. At this point, again, since Spring 2.0, this has been around, and that's been a number of years now, most Spring applications are using these in some fashion, if not extensively. And by the time we get to Spring 3.1, which was released just at the end of 2011, just around New Year. The support is quite comprehensive. This is a quick look at all of the namespaces available. And if you browse through these and look at the documentation, it's really a bit like browsing the feature set of Spring. What Spring can offer to your application is really quite extensive at this point. And again, here we're talking mostly about dependency injection, but it goes far beyond that. So namespaces make things better. They work very nicely. But you do still have to declare your application components, like the transfer service, like the account repository, the fee policy. Those still have to be declared as individual bean elements. And that brings us to the third style, which we call annotation-driven injection. And these annotations might be familiar to some of you, at AutoWired, at component, and an additional namespace element that came along with this support, this idea of component scanning. So we'll see how that works in a moment. For example, this line you see here, context component scan, for this base package. So everything we've been dealing with, like our transfer service and so on, is inside of this com.bank top-level package. This is telling Spring, look through that package and every package underneath it for any of my classes that are marked with this component annotation, and register it for me into the Spring container, just like as if I had done it in XML myself, but do it automatically for me. And wire up all of its dependencies, do all of the dependency injection automatically as well. We'll see an example in a moment, but this has been around since Spring 2.5, so also quite mature at this point. And at the same time we developed this functionality, we also introduced what we call the test context framework, which is a mechanism that aims to make integration testing in JUnit and TestNG frameworks much easier, introducing dependency injection into integration testing, into unit testing. Let's see that. Let's see what happens when we bring annotation-driven injection into the mix. So this is the third project, style 3, AutoWired. And if we look at the main method, nothing has changed. It's still being bootstrapped by this app-config XML. So let's look at that. And it's quite minimal. Some stuff is still familiar, right? Property placeholder is in there, our embedded database, configuring transaction management and a transaction manager. But everything else is now this one-line context component scan, like we just saw. So like telling Spring to look through every component under com. And find which ones should be registered as Spring beans. So to see what that really means, let's take a look at the default transfer service. And the definition has changed now. It's still the same, it's so fundamentally, but it has a few annotations. This at service annotation at the top, you can see in the hover that comes up, it's org Spring Framework stereotype service. And actually, service is itself marked as at component. So when Spring component scanning work, it notices that default transfer service has this annotation. And it registers default transfer service as a Spring bean. And it continues looking through the class and notices that it has this AutoWired annotation at the constructor level, which is telling Spring, when you create me, the default transfer service, please inject or automatically wire or auto-wire my dependencies into me, right? And I depend on an account repository and a fee policy. So there had better be a Spring bean, another bean in the container of type account and one of type fee policy. And if we look at those components, Like if we look at JDBC account repository again, indeed, it's marked with one of these stereotations as well, ultimately a component. So Spring will notice that as well. It'll register the JDBC account repository into the Spring container. It'll make sure that its dependencies are injected for the same reason. Auto-wired is marked here. Have the data source still getting created in XML, the embedded data source, JDBC embedded data source element. So we definitely have a bean of type data source, so that auto-wiring, that dependency injection will happen successfully. And the other dependency that the transfer service had was on a fee policy, and slightly different. Again, it's still a component, this org Spring Framework stereotype component. So component scanning will find it. It has a dependency, but it's not a dependency on another Spring bean. It's not a dependency on another Spring managed object. In this case, it's a dependency on a value. For a flat fee policy to be created, it needs to know what its flat fee value is, what that double value is. That's still going to be coming from our app.properties. You notice the dollar brace, tokens. That replacement process is still going to happen here. It's even still the context property placeholder that's going to do it, and we still have that configured in XML. So it's all going to work. The end result of this configuration style is the exact same objects existing in the Spring application context, just as if they had been registered via XML, but we're doing it in maybe a more convenient fashion, where there's no extra artifact to update. We only need to add components and auto-wired on the classes that we care about. We don't have to go type out bean definitions in XML for each of these. So it's definitely one of the benefits. What does this get us then? Annotation-driven injection gets us to the point of something really concise. There's almost no configuration. Therefore, pretty convenient, especially while you're developing. It's very convenient. At this point, again, it's been around for a long time, so it's become pretty widely used. It's certainly been a success. A lot of people use this. And one of the places where it's most widely used is in modern-day Spring MVC, which is really based on this model. We even sometimes call it at MVC because it's really relies on this idea of annotated components, particularly at controller, which is like service and repository, ultimately an at component. It's a decentralized approach when you compare it to Spring XML. And what I mean by that is that there's no longer necessarily a single location or single blueprint to look to. This could be something of a downside to this approach. It's not as easy to reason about the entire structure of the application. If your team is quite comfortable with this annotated style and they understand the mechanism, it's probably not an issue. But it's something to consider, right? How do you want that to be laid out? Do you want a single central artifact with a somewhat higher maintenance cost? Or are you comfortable with a more decentralized approach and a smoother maintenance process where there's simply fewer artifacts to update? There's no one answer to that question. It's really a matter of personal preference, team familiarity, etc., team size, and so on. This annotation-driven style, as far as we've seen it, still requires XML to bootstrap. We still had to have context component scan in the mix, that namespace element. We'll see about even getting rid of that in a little bit, but so far still requires XML. And definitely when you're thinking about at components, at auto, etc., XML is still necessary for dealing with third-party components. And when I say third-party, I mean our data source, for example. It's an embedded data source here. Imagine it's an Oracle data source. You're probably not going to go add at component to Oracle's data source object for obvious reasons. So third-party components still need to be externally configured as opposed to internally configured with annotations. Which brings us to Java-based configuration. With Java-based configuration, if you so choose, you can arrive at a situation where there's no XML involved at all. And the model here is that instead of Bean's XML documents, you're authoring configuration annotated classes. Likewise, instead of individual Bean XML elements, you're writing Bean methods. And it looks something like this. Right? Instead of a Bean's XML document, we've got this configuration annotation at the top of a class, normal Java class. Enable transaction management. That's doing exactly the same thing as TX annotation driven. Individual Bean methods, again, like Bean elements. And this is where it starts to get special, unique, different. Inside of those Bean methods, you really have complete control. It's not declarative, it's programmatic. And that might be a real feature, right? It might mean a couple extra lines of code, even compared to XML in some cases, but it also might mean a lot more power and a lot more freedom, depending on the kinds of objects that you're working with. Maybe they don't have normal Java Bean setters. Maybe you want to put a system out print line in the method just to see when it gets called, for example. You really can do, it's just a method, so you can do whatever you choose with it. But the idea is, if you have this quote service object, for example, that you want to be managed as a Spring Bean, you instantiate it, you configure it. You actually call the setters, call the constructors, etc. But by the time you return that object, when that quote service object is returned from that Bean method, at that point, it's managed by the Spring container. It becomes a Spring Bean just like every other Spring Bean, regardless of where they came from XML, from annotations, now from Bean methods. By the time you get to the Spring container, they're basically all the same. So creating a Spring container when you're working with configuration classes is basically the same model. So far, we've been using Spring's generic XML application context, which of course takes an XML file as a configuration. Here, annotation config application context is of course taking the class that we just wrote, taking configuration annotated classes or even component annotated classes. Basically anything that's doing configuration based on annotations can be fed in as input to this application context, which means that we get this really nice, all Java, all the time, type-safe approach to working with Spring. And there's really no XML involved. At the end of the day, you're still using that Bean just like you would have if you were configuring with XML. You're calling a method on it and doing some business at the end of the day. So let's look at our application again in light of Java configuration. So here's our transfer script. And the main method has changed, right? Just like we saw a moment ago, it's using annotation config application context. But you can see the structure of that main method is basically the same. It's literally just a different variation on the application context. And let's look at the configuration class itself. So pretty similar to the slide that we just saw. Add configuration at the top, enable transaction management. Even our app.properties is included here. It's being added with the property source annotation. This was added in Spring 3.1. And if you look at the rest of that class, it actually feels structurally pretty similar to what we've been doing in XML all along. We have to create a data source. We have to create each of our components, wire them up, return them. You can see how properties work is a little bit different. It's not about the replacement of tokens with the $ and braces, but rather we're looking at flat fee amounts, minimum transfer amounts. We're looking those up against the Spring environment object. And that's also new in Spring 3.1. Can't go too deep into it in this webinar, but some quite nice support for a unified approach to property management, hierarchical in nature, working with property files, environment variables, system properties, servlet context parameters, et cetera, et cetera. So that's something to look into beyond this, but it all works very nicely with the configuration model. And our transfer tests has also changed a bit. This is the test context framework again that I talked about before. And here, instead of looking to an XML file, this functionality was also updated in Spring 3.1, so that instead of a set of locations pointing to XML files, it can take a set of classes to use to configure the container, to inject dependencies into the JUnit test even, and then run those through their paces. So again, JUnit itself even gets the benefits of dependency injection. We don't have to manually create an application context. We don't really do any sort of dependency injection here. We just reuse the existing configuration. Again, it's like the only factory you'll ever need. That's the goal, one of the goals that we're trying to meet here, even for unit testing. Okay, so you get a number of benefits here as well. Safety. We've only scratched the surface with configuration classes. When it comes to modularity and structuring these configuration classes, you actually have the benefits of object orientation even. So that becomes a pretty interesting topic. You can configure anything, third-party code, your code, you can do it all inside of a bean method. And again, you have full control. There's no tooling required other than your IDE because it's just Java. And the support is very complete as of Spring 3.1. Those enable annotations do a good job of matching most of the existing functionality in Spring XML namespaces. So you can really do just about everything, pure Java, if you like. And very importantly, you can mix and match this style with the other styles. And that's kind of the point of the fifth style, hybrid configuration. Really, this is probably the goal. There's not really any one style that's better than another. The idea is understanding everything that Spring makes available, choosing from the different styles to meet your particular needs in different areas of your application, for different layers in your application, et cetera. There's not really a silver bullet here. There's no argument to be made that Spring XML is categorically better than annotation style, or that Java-based configuration is better than all of them. It's much more that they're designed to work together. Like I mentioned, you probably want to use annotation-driven injection if you're dealing with Spring MVC. Almost certainly you want to. You may want to expand it to the rest of your application as well. For third-party components, you might really like wiring things up in plain old Java inside of a configuration class. Maybe you have existing, a large existing number of Spring XML files, and you don't want to translate them. There's no value in that. So you could easily imagine a situation where there's some XML, some annotation-based, some configuration classes. It's just taking whatever the pragmatic approach is. And the most important thing is understanding what's available and what the pros and cons are. So very quickly, I'll show you the style 5, the hybrid style. And you can see that we still have an appconfig.xml file where we decided to put our property placeholder in XML. And actually, a little feature of Spring 3.1 we're peeking at here, this idea of bean definition profiles, where so far we've been dealing with an embedded database, which again is maybe appropriate in early testing or in early development cycles. But by the time this gets to production, we probably are a real data source, maybe one coming out of JNDI. And so this file actually should be self-explanatory. If the current profile configured against the Spring container is called production, then grab our data source using this JNDI lookup. Otherwise, if a profile isn't called production, the default scenario, use an index. And so the default scenario might be dev, just normal development. And so we're always going to work against that embedded database. Again, that's a little bit of a different topic. It's something to check out, especially if you have the opportunity to use Spring 3.1. So there's a bit of XML here, and there's also a configuration class. And just to show one feature about how these can mix and match, we can't show them all in such a short talk, the import resource annotation. And you can see the configuration class is kind of pulling in or importing the app config XML. And that means that we can create the application, that we can bootstrap the application from a Java-centric view using the annotation config application context. So everything's driven in the Java-oriented style. But, yeah, there's still some ethics, and this kind of mixing and matching is, again, really designed for, assumed to be the case. Okay, a few things to think about, and then we'll throw to questions. One of the decision points that you can be thinking about, which style should I use where, is this idea of ease of use versus centralized configuration, centralized blueprints, maybe better for long-term maintenance or for new developers to get a quick sense of the application. An XML file, a Java configuration class, acting as a blueprint can be a nice artifact to have. But it requires a bit of extra typing, whether it's typing in Java or typing in XML. Whereas component and auto-wired and that support is really very easy to use, quick to get up and running with, quick during the development cycle. That's a trade-off that you want to understand the pros and cons of and choose, again, based on personal preference, based on team experience, etc. If you have these sprawling, out-of-control Spring XML files, there really isn't any excuse for that anymore from the point of view of the framework. There are plenty of options, whether it's breaking them up into smaller files or the namespaces that we talked about, or going toward annotation-driven config to manage Spring XML so that it really is valuable when you look at it, and it doesn't just seem like a bunch of noise. And again, it really is possible to have no XML at all if you choose, if that's something that you want in Spring 3.1. And I'll just reiterate that we've been talking about dependency injection here, but Spring begins with dependency injection and is built on the ideas of dependency injection, but is so much more than that, whether it's transaction management or these many other features that we simply don't have time to talk about here today. With that, I'll open it up for questions, and these links you should see up as we go to questions. Again, I would really encourage you to look back to the presentation. It's online at that link. Check out the code, play with it, mess around with it. It's really intended for the viewers here today to play with, so please do. And this presentation will be up on the web at the YouTube link that you see within the next week or so. And of course, check out the Spring Source blog if you haven't before. So with that, we're going to go to questions. What is OXM? Object XML marshalling. So that's like going from an XML file to an object, or from an object back, kind of like Hibernate is for a database, but for XML files. Yeah, and don't forget the GFE namespace for Gemfire. Yeah, it's just not part of core Spring. That's actually a nice point, though, that Spring's namespace support, the ones that I showed you are the ones that ship with the core framework. And what you'll find, if you go look at all of the other Spring projects, Spring Integration, Spring Batch, Spring Data, all of the Spring Data projects, like for NoSQL stores and so on, Spring AMQP, right? Spring Genfire, Spring Hadoop. All of these projects ship with Spring namespaces that make configuring those projects really, really easy. So it's a nice point. What if there are multiple beans of the same type? Then how does auto wiring work? So actually, if you look at the applications, they were actually built with this in mind. For example, the transfer service, default transfer service, depends on an account repository. And there's an account repository interface. There's actually two implementations of account repository in these projects. There's the JDBC account repository that we've been dealing with, and then there's also a simple account repository. They are both of the same type, ultimately. It's the one that is annotated with app component. That's the one that gets chosen. And if there are two that are annotated with component or repository or what have you, then there's a qualifier mechanism. The app qualifier annotation can help to disambiguate or to choose for the container to help choose between them. Can't fully explain it just in a quick answer here, but if you look up app qualifiers JavaDoc, you'll see the answer to that. And then a nice question about the pure Java annotation style. In the pure Java annotation style configuration classes, every call to data source will create a new data source object. Or, for example, we had a transfer service bean method. Will every call to transfer service create a new transfer service bean method? No, because in reality, those bean methods are enhanced by the Spring container. There's a proxy involved that helps take care of scoping semantics. So by default in Spring, all beans are singletons. And Spring app bean methods are also singletons. You can configure them to be prototype or session scope or request scope or custom scope, but by default they're singleton, meaning that method will actually only ever be called once by the container. And then after that, the object that was returned is managed in the container and cached as a singleton. So you're safe there. What else? Does it mean that with Spring 3.1, if we don't wish to use XML, we don't have to? Yes, that's correct. Even beyond Spring XML. Spring 3.1 even has mechanisms that let you get rid of web.xml, even getting rid of servlet XML. If you look at the web application initializer, JavaDoc, you'll see how that works. Pretty cool. Any recommendations between choosing setter-based and constructor-based injection? I believe it would apply to any of the styles we discussed today. That's definitely true. That's a common question as well. And there is no one right choice here. The choice between a setter and a constructor is not a question for Spring. It's not even really strictly a dependency injection question. The question is really, is that object required? If the object, like the account repository, is really necessary for the transfer service to function. If the transfer service doesn't have an account repository, you will quickly see null pointer exceptions. It's best to accept that object then as a constructor argument, force it, make it required. If it's truly optional, like there's a default value, if you don't inject it, then that's really appropriate for a setter. That's a nice rule of thumb anyway. Do we have to create an application context for each bean we want to use with Java-based configuration? No. In this very simple application, we did that. We created an application context and only got one bean out of it. But this is a very important point, and it's actually a common question. In any given application, great big web application even, there should only be one Spring application context. It's a very odd situation if there's more than one. There are valid use cases, but it's very rare. One, in web applications, sometimes or often there's two, the root application context and the servlet application context. But for the purposes of this conversation, you can think that there should only be one. If you find yourself instantiating Spring application contexts here, there, everywhere, this is definitely the incorrect approach. There should only be one. How should we integrate Spring in an existing code base that is just a library? What I've been showing you here with Spring so far is more of an application-focused approach, like how you would configure and bootstrap an application. If you have a library and you want it to depend on Spring, it really depends on what you're doing. So it's not an answer that I can give very quickly, but your library probably won't be creating any application contexts. Depends on what the library does. But you could certainly rely on many of the things that Spring makes possible. I just have to know more about the library. Does the component scan have any overhead when the number of classes are huge? There is certainly some overhead to component scanning. Indeed, we're having to go look through the class path. That's why we narrow it down with this base package parameter. It would indeed be very slow, or potentially very slow, if we just scanned the entire class path, right, from the root package down. By the time you say com.bank, you've already narrowed the field probably quite a lot. And so if you're dealing with hundreds or even 1,000 or more classes, even 2,000, 3,000, component scanning will still be quite fast. We're using ASM bytecode library there that's quite quick at what it does. And it's very important to point out that even if component scanning took like a whole 1 or 2 or 3 seconds, which it usually never would, that's not necessarily such a problem. Why? Because that's happening only when the application is being started, not at runtime. So you might have to count 1,000 to 1,000 for an application with many, many, many classes in an extreme case, but your users won't. The operator starting the app, the developer might, but the user won't. That's a very important distinction. Does configuration mean that we completely replace XML? It means that it's possible to, but from Spring's point of view, they're both first class. XML will always stick around. Any restrictions in making setters, getters, private, public, default protected? Spring is capable of injecting into non-public setters. Is there a difference between a servlet context and the app context? Yeah, definitely. The servlet context is what your servlet container is giving you, what's holding the servlets and servlet listeners and so on. So that's managed by the runtime. Spring application context is basically just an object that's managing all of your other objects, all of your other components like the transfer service and so on. So there are a couple of touch points where an application context can interact with the servlet context, but they're mostly separate. Latest Java EE introduced EJB3 and JPA, which has full annotation support. How Spring compared to the new Java EE structure? Yeah, so what EJB makes available in terms of annotations and dependency injection, it can certainly be compared to Spring, right? You can use add resource to inject things in a way that's similar to the way that you can inject with at AutoWired. Definitely not the same, and we'd have to really get into it here to go into the details, but EJB3 has a similar component model to Spring. Even many of EJB's annotations we actually support in Spring. So EJB's transaction annotation we support. The at resource annotation that I was just talking about, which is actually part of JSR 250 common annotations, but we support that as well, just the way that EJB3 does. So there's a fair bit of overlap and similarity there. When it comes to JPA annotations, Spring doesn't really address that area directly. Spring provides support for building JPA annotations, but Spring doesn't try to reinvent JPA. Spring doesn't provide its own, for example, at entity annotation. We rather integrate with JPA-based or Hibernate-based applications and allow you to use those annotations natively. So that's a bit of a different story. That was quite a few good questions. Sorry if we couldn't get to all of them. One of the links that you don't see here is the SpringSource forums. Of course, you can always ask questions at forum.springsource.org or at Stack Overflow, the Spring hashtag. at Stack Overflow. And I really appreciate you attending today. I hope we'll see you again, and I hope you enjoyed. Okay, thanks.